our guest, which is Okko Ringena from UPM. He is the Senior Manager of Sustainability at the Biochemicals business part. And he is working with UPM's project to build a full-scale biorefinery in Leuna, Germany. So with those words, I'd like you, Okko, to take the stage and further introduce yourself and give us your presentation.
Thanks for the kind introduction, Jonas. Thanks for everybody for interest. I will now in the coming 15 minutes roughly try to explain a bit more about why we are entering in general the area of biochemicals, and obviously as well a little bit more about the project that we are going to build here in Leuna, Germany. That's where I'm as well currently located. But before we dive into the subject of today, we have one or two slides on UPM in general. And I guess most of you are familiar with UPM as a company, so 19,000 employees or a bit shy of that. And as you can see, the majority of our revenue is generated in Europe, so 62% of that, so strong European footprint. And not surprising for a forest product company like UPM, we process significant amount of woody biomass, so approximately 27 million cubes of wood every day. And as well, since many years, things like chain of custody, certification of forest, etc., biodiversity is on top of the agenda of things that we do, and it obviously as well will apply for the new project here in Leuna. Before we look into the actual project, I think very well known from a forest industry, not so much maybe from other industries, this material hierarchy to avoid generation of waste, and actually it gives a possibility as well to align our different businesses here. So starting obviously with logs for sawn wood and plywood, for instance, then fibers which can obviously be used and have been used for pulp and paper, but then new applications as well. So today we look into utilization of fibers for biomedicals, for instance, as microfibrillated cellulose or 3D cell culturing, and then biocomposites as well, utilizing fibers, then combination with polyolefins, for instance, for injection molding. And even a step further down when it comes to, let's say, molecule scale, is then to decompose the woody biomass all the way to its building blocks, lignin, cellulose, and hemicellulose, and even further to hydrolyze cellulose and hemicellulose to monomeric sugars and convert those to biochemicals. And that's what we are doing, and that's what I will explain more in a second. And then obviously as well, extractives mainly from hardwood can be converted into renewable diesel. We have one plant in Lappeenranta, Finland, where this is done. And as a side stream and very high on the agenda of many kind of companies at this point of time as well, bio-naphtha, which is as well a feedstock for producing of chemicals. And what's left, potentially sometimes the bark, but then lignin branches, etc., can be used to produce renewable energy. So there's nothing to waste when it comes to woody biomass, which is maybe as well an important feature of bioeconomy in general, that you try to maximize the materials you can produce out of your raw materials. Looking at UPM, and we have defined certain spearheads of growth, like we call them. So that's growth businesses for UPM going forward. And in the middle of it, that's high value fiber, quite obvious, I guess, for a company like ours, for instance, in packaging world, but then tissues, hygiene, paper, etc., where there's still growth expected to happen. And we are currently, as we speak, as well, building a new pulp mill in Uruguay. Then on the left-hand side, specialty packaging materials, as well, there we see a demand to provide alternatives for today's packaging materials, and that's why we will emphasize as well this part of the kind of business. And on the right-hand side, that's more the chemical branch of it. We call it molecular bioproducts, which combines biofuels business and then our biochemicals business. For all of those, we see growth going forward in coming years and decades. So why now biochemicals? Obviously, one reason for us to enter this business because we see long-term really strong growth for development and marketing of sustainable and renewable chemicals. Why is that? Obviously, we still see population growth in many regions of this world, and as well increase in living standards, which usually result in higher demand for different kind of materials. And when you look to chemicals, there specifically a high growth is forecasted. So CEFIC has estimated that the chemical market will duplicate between 2018 and 2030. So that's significant growth expected in the area of chemicals market. However, on the flip side of it, obviously we have as well sustainability targets. So EU to become climate neutral 2050, Japan 2050, China 2060, and potentially other regions will join this as well. And it's quite obvious that you need to find more sustainable alternatives compared to the fossil-based chemicals, which, as we speak, still absolutely dominate the materials which are produced in that sector. And that's why we believe this will provide us nice possibility to enter the space of bio-based materials and provide renewable carbon into today's value chains. About the project that we are building here in Leuna. So it's a significant investment, a bit more than €500 million into an industrial scale biorefinery. So it's really, it's not a demo plant or a flagship, it's really an industrial scale refinery, as you can see as well from the capex, which is mentioned there. Capacity will be approximately 220,000 tons of products. And as said, it will provide alternatives for fossil-based materials used today. Our board of directors has approved this project in January this year. So we are basically roughly a year down the road now in the project, and it will be still 2 more years. So scheduled startup of the facility is end of 2022. On a high level, you can see the technology that is applied. And in this combination, it's first of its kind. So it has never been applied like we will do it here. So maybe if we start on the feedstock side, so we use hardwood, more specific, mainly beechwood, which is the natural species here in Germany, which makes people believe that it will be more resilient towards as well global warming. And the other side is that it's as well abundantly available because the forest industry until now has mainly focused on softwood for various reasons. So hardwood, beechwood, that will be the feedstock that we are going to process. And it will come from regional sources. So in a close radius around the mill, there's abundant availability of beechwood. And there's 2 streams. So one is residues from sawmills, sawdust, basically that we will process. And then it's industrial wood, so small dimensional wood from thinnings during normal forest management operations. The first step, debarking and chipping, that's very similar to what we see as well, for instance, in pulp mills. And then the chips are converted to the next step. We call it wood to sugar process, where basically the main building blocks of the wood are separated from each other and then processed in individual streams then further on. So cellulose, hemicellulose are separated and monomerized, and then in a one-step process, we call it sugar to chemicals, converted into one of our main end products, which is monoethylene glycol, as shown here. And I will tell more about the end use of these products in a second. Then the lignin, as well, the lignin we will utilize as a material, so not just for energy generation, but it will be converted into what we call renewable functional filler, which is a replacement for carbon black in the rubber industry. So those are the 2 main end products. And then there's a possibility to extract as well sugar streams to sell to external customers, for instance, in the area of biofuels. But let's have a few more words on the two main products. So that's bio-MEG and then the renewable functional fillers. Starting with MEG. MEG, it's a so-called drop-in product, meaning it's exactly the same molecule when we produce this compared to how it's produced today from fossil feedstocks like coal, oil, or gas. So there's no difference, and as well the same specifications, which means that our customers and the entire value chain, they don't need to change their processes, which is positive because you can, with your existing kind of converting technologies, you can simply switch from fossil-based MEG to bio-based MEG and benefit then from improved sustainability of the material. As well, with regards to recycling, this obviously is an advantage, as we will see later on. Materials that are not recyclable, it will be very difficult, I think, to justify them on the marketplace for decades to come. As such, MEG is one of the largest chemical intermediates. Today we talk about demand of roughly 30 million tons, and it's growing around 1 million ton additional demand per year. And it's used for products like you can see there on the right-hand side. PET bottles, maybe that's the best known, but then as well textiles, for instance. Whenever you look at your shirt or whatever, it says polyester, it's this PET, which is used there, and MEG is part of PET. So there's various end users which as well have customer proximity, which is good when you think that our customers want to promote then the benefits of bio-based content as well towards the end customer. Yes, one word on circular economy and challenges there. As we all know, unfortunately today, plastics still suffer from mainly linear processed material flows. And obviously this needs to change. And I borrowed this picture from Ellen MacArthur. I guess many of you will know it already. So starting from maybe reduce, which is not mentioned here, but potentially that should be the first one. Then reuse and recycling of materials will be the key as going forward to at least come close to the targets, environmental targets that have been set and which are urgently needed. But even in a perfect circle or cycle, there's always losses which are inevitable. So you will never collect 100%, and as well recycling processes, they will never have a yield of 100%. Plus, as mentioned before, there's demand growth, and so you need to fill those gaps, and obviously that's where we come into play, providing renewable carbon, in this case renewable MEG, then to the value chains to fill for this additional demand. The second product, the renewable functional filler, that's, as I said, it's lignin based. And it will be used to replace carbon blacks and silicas, for instance, in many rubber applications. So the one example is a tire of cars, for instance, where it's very obvious, but it will be used as well in many other rubber applications like hoses or ceilings or colors as well. When you look around you, you see black material, plastics, usually that contains then carbon blacks. And the difference of this renewable functional fillers against MEG is that it's not a drop-in, because our RFF is not exactly the same molecules, has not exactly the same molecule structure like carbon black, which on the one hand side is a challenge because you need to, let's say, invest heavily into application development jointly or with your customers or yourself to adjust then for the formulations and recipes of your customers. On the other hand, this RFF has then specific advantages, which obviously as well then benefit additionally. So it's, for instance, it has lower weight compared to carbon blacks, or it's as well long-term biodegradable, just to name two of those ones. And obviously for all products, they have a significantly reduced carbon footprint compared to the fossil-based conventional products used in the industry today. And we believe together, utilizing the lignin in form of renewable functional filler and utilizing the carbohydrates in the form of mainly MEG is as well a nice balance you have a high use of materials or raw materials that you convert into materials, and B, it's a nice mixture of a drop-in and then a more specialty product like the RFF. Woody biomass, I just have this one slide. We believe wood will be very important for biorefineries going forward. Maybe not in every case. So we looked when we made a decision to go for this specific sites. Obviously, availability of woody biomass was key for us going forward. But maybe in other areas it can be totally different raw materials which are used for biorefineries. So it's always a question in a certain area, what kind of biomass is available in a sustainable manner, so long-term sustainable supply of biomass. Can be waste streams, it can be first generation biomass, it can be algae, but in our case, obviously, we focused on wood quite heavily. So the benefits, I mean, they're quite obvious that as a feedstock, it's obviously climate neutral certification. So many of you will know FSC, PEFC, that helps as well to kind of explain to the end customer where the origin of the wood and that it's coming from sustainable managed forest, and we will utilize 100% FSC and or PEFC certification from day one in this biorefinery. Then it doesn't compete with food generation, as already mentioned, chain of custody. That's already been developed since many years in the forest industry. And as well, the regional context, I think it's important. So it's short supply chains, which hopefully are resilient, and it's very good traceability. So basically, you can follow from the feedstock from the forest, you can follow the raw materials to our mill, see how it's processed there, and then as well, within one day, you can go to the customers and see how it's converted into final products. So the regional context, I think it's one of the feature of biorefineries as well. And as said, we will utilize, let's say, small dimensional wood from thinnings or then residue streams. Then on the site, here you see the overview about the chemical site in Leuna, which is 200 kilometers southwest of Berlin, very close to Halle or Leipzig. And it's the largest site when it comes to area in Germany. So it's roughly, I think, 13 square kilometers. And we will occupy those two plots as shown here. So this plot on the right-hand side, that's the biorefinery. And then we will have an area for storage of the wood. And we looked into many sites before deciding going to Leuna. And obviously advantages of a chemical park in general are that there's site management, which provides utilities like steam, like electricity, like wastewater treatment, on services like firefighting brigade, security. So you don't need to invest all of this by yourself. And obviously they are always located in, let's say, good, from a logistics perspective, good locations. So there's train connections, as you can see, for inbound of feedstocks and outbound of products. And as well, obviously, as well, good connection towards the highway. So that makes this general concept of a chemical park as well very attractive for biorefineries. And some of you might know that there's this Fraunhofer Institute as well for biorefineries located adjacent to this chemical park. Yes, and you see that already some earthworks are taking place. So we had the official groundbreaking ceremony on October 7th. If you're interested, you can go to YouTube and have a look at it. So that was streamed live, and basically the plot behind the guys, that's where the refinery will be built. And now the first year has been mainly to do the preparations, permits, and ordering long lead items, all those things that you do in the early stage of a project. And then starting from early next year, the actual construction work will start. So if there's a chance and we can give another update 1 year from now, certainly it will look completely different from where we are at this point of time. But as said, the next 2 years will be extremely interesting. We are very excited. And for me, it's first time to participate, and I think for many others as well. such a project, and we are excited and extremely motivated going forward. And I hope it was only 15 minutes, but I could give you a quick overview about why we are entering this business and what's the current status, and happy to receive questions if there are. Thank you.